In this lesson, we will talk about iterators in Rust. Iterators is not a concept just for the Rust programming language, but we will see this in details for Rust. And what are iterators? Iterators are a way to provide this powerful and flexible way to process some data. Just to have an idea, you can think about the for loop. The for loop under the hood, it uses an iterator, and they can transform, filtering, aggregate elements. We will see examples with the famous map, filter, and reduce. In Rust, it's called fold, but we also have a reduce method now. Why iterators? Unlike the traditional loops, so we made a lesson about the loops. In Rust we have loop, while, and for. The Rust's iterators are lazy. What does it mean? Lazy means they do nothing unless it's strictly necessary. This is very memory efficient, I would say. We'll see an example. Usually we can also combine different iterators to do even multiple transformations in multiple or single passes, on single steps, I would say. But this is just to have an idea. Let's see an example, because I think that when we see an example, a code example, everything becomes way easier. Let's see the first example. So we can define this vector using this vec macro. This is a vector of iter32s, and we have 1, 2, 3, and here we can define this variable called v1 underscore iter. You see, we have this v1.iter. We have never made this so far. And then to have an idea, we can use this for loop not on v1 but on v1.iter, like this, and then we can just print the values just to see what's going on. And here we can type cargo run like this, and as expected here we have got 1, 2, and 3. So we are iterating through this vector, okay? But now I want to stop for a moment, and I want to try to understand how iterators are done, how do they work behind the hood, because I think this is very important, okay, just to understand. And this is, by the way, how also other loops they work, okay? How can we do this? I want to define here below the main function public trait, which is very similar to what the real iterator trait works. We can have this public trait. We made a lesson about traits. You can think about traits like interfaces. And then we have this trait. Here we have something that we never saw so far, which is type. Here, this is an associated type. You can think, we will make a specific lesson about associated types, but for now you can just think about it as the item that we will return, okay? The thing we can return. We can return everything with iterator. And then we need also to implement this function called next, okay? That basically it steps into the next element of this iterator. And check here the return type. It's an option. What is an option? Is an enum that has two possible values, some or none. Okay, this is because in Rust we don't have the null value. We can just have an option that has either some or none as a return type. I think it wants the capital I, okay, but this is just an example. Now let's see the iterator in action. So I want to see the iterator demonstration. Okay, to do this, I want to use what we used when we were talking about test. Now, to do this, we should create a separate library, run proper test. Nobody's stopping me to call this assert equal in the main function. Okay, so let's define this other vector. I want to change the numbers here. So we just can differentiate from the previous one. And then we can define a mutable iterator, v1 underscore iter, and then based on this, let's make some assert equal, okay? So we are basically checking what's going on when we call the next function. So we are at the beginning, when we have this, we are checking, is this returning 10 on the first step? And then, is it returning 20 on the second step? And then 30? And then, last one is no. And then we can try to run this one, here, cargo run. We don't have any output here, but we see that it's not returning an error. For example, if I skip this step here, for example, I comment, and I can check the assert equal. If 10, we have the 30 element, so the element number 3 on position 2, we can see that we have an error. So this is just to demonstrate how the iterator works. So it basically makes one step by step, and it checks everything which is inside the collection. It can be a vector, it can be an array. We can implement our own iterator. In this lesson, we will do simple examples, so we will mostly use vectors and arrays. Okay, so this was just an example of how the iterator works. Okay, so now let's talk about the types of iterators in Rust, because in Rust there are different types of iterators. Okay, let's see, because for now we saw just one type, which is this one, iter. But let's start with the first one. Okay, so the first one is this one. Like here, we can call this one. So the first one is .iter, okay, which is what we did so far. Okay, and for all three of these types, there are three types of iterators. So we have a purpose, ownership, and use case. So purpose, why that exists, the ownership, how it works with ownership, and then the use case, a good use case for it. So let's check this one. Let's remove this. I hope you can read it. So .iter, the purpose is to create an iterator that borrows each element in the collection. So we want to borrow the elements. Think about an iterator, something that we can call on a vector. For ownership, so how does it behave with ownership? This iterator yields some references, but not own values. What does it mean? It means that the original collection that we used, it doesn't change. We can consider this like going in read mode. Okay, for example, as you can see, use case, you can use iter when you want just to read or inspect some elements, but we don't want to modify them. Okay, for example, is what we did so far, but let's see an example here. So we can define numbers as a vector, it's fine. 1, 2, 3 here, and what we did so far is that we can do for num in numbers.iter, and then we can print it. You can see, as you can see here, we are using this .iter, but we are just basically reading it. An important thing is that after I just read these elements, or I did something, but without modifying them, this is still accessible. Okay, println, so I can on line 47 still print this one. I want to make another print statement here, .iter, like this, just to see that we are here. Okay, and now if I type cargo run, let's see. As you can see here, we still can use the numbers here, and we are just reading here. So we have still 1, 2, 3. Okay, this is the first type of iterator. Okay, now let's see another type, the iter underscore mute. As you probably guessed, the mute stands for mutable. Okay, so what's the purpose, the ownership and use case for this second type of iterator? So the purpose is to create this iterator that borrows elements in this collection but mutably. We'll see this soon in an example. As a ownership, this iterator yields a mutable reference like this, and it allows to modify the elements. Okay, so we can modify the elements of the collection. We never modified the elements in the collection so far. And we can also see, of course, how we can do it as a use case, of course, when you need to change the elements of a collection. Let's see this with an example because it's easier. So let's create, in this case, a mutable vector. How we can do it? We can add just the mutable variable. We are getting a warning because we are not modifying it yet. Just give us a couple of seconds. And then, for example, we can type for each number in, you see, numbers.iter mutable. We can have this asterisk num plus equal 1. Okay, so what does it mean? I also want to print it here. Print it, println with this one, got. And then at the end, I want to again print, try to print these numbers because we are still borrowing the variables in a mutable way. Okay, so here we are dereferencing each element. Why? Because when we want to modify, we are getting the collection by reference, but then to modify this, we have to dereference it. We never made a lesson so far about the dereference trait. For now, it's enough to consider that when we get, for example, this collection of vectors, and if we want to modify these original numbers, by the way, we are using shadowing here. You see, I can use the same variables on line 41 and then 56. I think this was the lesson number 2. We can use the shadowing, and let's see here what's the output. So Control L, cargo run. What do we have here? We have, okay, so iter 1, 2, 3. We are interested into this part. We have 2, 3, and 4. So we are modifying this existing vector here, and you can see at the end we can still access numbers which effectively has been modified. So when we run the println on line 64, we don't have 1, 2, 3 anymore, but we have 2, 3, 4. So we effectively changed the numbers. Okay, and this is the second type. We still have one more type, which is the into iter. So let's see for this what's the purpose, the ownership, and the use case. Here, into iter. The purpose, what is to consume this collection. We want to create an iterator that takes ownership of element. I hope everyone has the concept of ownership clear. Otherwise, I have many lessons about that. So in this case, the ownership, the iterator yields some owned values. So after all the iteration, we'll see this an example soon, the original collection is no longer accessible. It's similar to what we did in the ownership lesson when we just used the variables without a reference. By default, Rust consumes everything you pass, for example, for functions. And this is a huge difference compared to other programming languages. When is this into iter iterator useful? When we want to transfer the ownership of the elements. Let's see an example here, of course. We can use again numbers. So we are using again shadowing here. I want to make examples as easy as possible here. We get these numbers, we don't modify them, but we use the into iter iterator, okay? And then here, if I try to print the numbers at the end, let's see what's the output. Cargo run, I want to do this another time. We have an error here. So we can't use the numbers collection again because we used the into iter type of iterator. So we basically got ownership on the collection. So here I can do whatever I want, but here the numbers collection is not accessible anymore. Okay, this part is very important because we need to understand the types, okay, of iterators. Summary table here. Let's see. I hope this is clear. We have as iterator what it does wield and the ownership and purpose. So I leave it here so you can give it a read. Of course, you can also take a screenshot or pause the video now. We have iter mute and into iter, and we have what it wields, the ownership type, and what's the purpose. Okay, so now let's see some methods that can modify or consume iterators. Okay, in this case we will see three of them. We will see map, filter, and fold, which is very similar to reduce. Let's define again. In this case I want to define an array. So numbers, how we can define an array in Rust? Just like this. 1, 2, 3, 4, 5. Okay, like this. Okay, so now let's see the map one. Okay, and as I said, Rust is a bit verbose as a language compared, for example, to JavaScript. We can define a vector like this, let's squares. As a type, this is very interesting. We can have a vector of underscore. This does mean I want this to be a vector, but I want the type to be inferred by the context. So please, Rust compiler, infer the type for me. This is what this vec in angular brackets and underscore does mean. Okay, and how can we do this? We can have these three methods. In this case, we have .iter. We are using the first type of iterator for simplicity. Then we have this map method, and then collect, because we can take anything which is iterable inside another collection. We need this collect at the end. We can print map squares, println. Okay, let's try here. I hope you're familiar with the map method, and as you can see here, I hope you can see it, we have basically the square of these numbers. The map method, what does it do? It takes every element, and on each element it applies something. In this case we are using a closure, so we are using a closure to get the context of this scope. Okay, and this is why from this 1, 2, 3, 4, 5 we have 1, 4, 9, 16, 25, basically the square of each element, but we get another collection back. We gave an array, we got a vector. Nice deal, I would say. Let's talk about now the filter one. It takes the collection and it returns another collection, but it filters out some elements. So we'll get the elements filtered. A classical example is this one. Let events, and we can start again from numbers, and then we can use the .iter, then we can filter just the even elements. So I want the even elements, so the element which is the remainder here is 0, and then let's try to print this, the filter with events. Let's see, cargo run, and as you can see here, for filter we don't have 4 and 16, we have 2 and 4, because as I said, just using this iter, it doesn't change the original array. So when we are defining these events vector on line 104, we are again starting from line 94. Fold, usually in other programming languages, is called reduce, so I'll type here, similar to reduce. Let's talk about this fold method. So we have this sum. In this case, sum is not a collection. This is important, because in fold we are consuming the collection using the iterator, and then as an output we have what? A number, an i32. So here what are we doing? We are using as an accumulator. Accumulator is something that we use to keep the value over this method. We start from 0 to the element 0. Basically, we want to use this function for all the elements in this collection of numbers. And then what? We need to do acc plus x. So basically, this is an easy way, for example, to sum all the elements inside this array. So what's the output here? Let's see. Let me know if this makes sense for you. And for fold, the sum is 15, because by summing all the numbers 1, 2, 3, 4, 5, we get 15. So this is how, for example, we can use iterators. Of course, these are very basic examples, I would say, but still sort of powerful. I hope you can see how powerful this can be. What are iterators? Iterators in Rust, they provide this way to process data, and with this next function, so we can go on the next element of the collection. We can transform, we can filter, we can change it, we can aggregate elements in a final single result. And it's very important to understand that in Rust, the iterators are lazy. So they don't do anything before they explicitly need to do that. And then this is very memory efficient. And they can also allow you to define and control ownership. We have 3 types of iterator. We have iter, iter-mute, and into iter, depending on what we want to do with this iterator. This is very powerful. In other programming languages, maybe we have just one. And then we saw some example of methods that they can use or consume these iterators. For example, for map and filter, we just changed the values, so when we return another collection. In the fold method, we consumed all the collection and we return a number, for example. And this is very powerful and expressive. I've been using map and filter and reduce a lot during my whole career. And I hope this lesson was useful. If you have any questions, just drop a comment below, and see you in the next video.